Hi class, how are you today? That's a thing. That's totally a thing. The learning target for today is to create and use information from a box plot. 3. You can create and use information from a box plot. 2. You can create or use information from a box plot, but not both. 1. You can identify the key parts of a box plot, but you don't really know too much about what they mean. You just can identify them. Like, that's a median, that's a minimum, that sort of thing. And 0, you cannot identify the key parts of a box plot. Let's get started. Alright, so let's start off with this dot plot here. So this dot plot is figuring out how many raisins come in a box. So to create our box plot, we need what's known as a 5-number summary. And those 5 numbers are as follows. The minimum, the smallest number, Q1, which is known as the first quartile or the lower quartile. We'll get into what that means in a moment. The median, the middle number, Q3, also known as the third quartile or the upper quartile. And by the way, just a note, the median is sometimes called the second quartile. And the maximum, the largest number. Now let's go ahead and fill these in. Well, the easiest to find are the minimum and the maximum. The minimum, the smallest number, 14. The maximum, the largest number, 35. Now the other 3 are a little bit more difficult to find. You know how to find the median. It's the middle number. So first count how many dots there are. Now here I count 34 dots. The issue with that, though, is that for the median, 34 is an even number, so that means there's no middle number. So you take the 2 numbers closest to the middle and find the average. So you would count 17 dots from the minimum and 17 dots from the maximum, including the minimum and maximum. So both of those dots lie on 30 and are specifically here and here. So the average of 30 and 30 is 30. So the median is 30. Now to find Q1. So after you find the middle dot, which in this case there was no middle dot, but whether there is or not, all of the dots before the middle dot, you now have to find the median of those. And that does not include the middle dot if there is a middle dot. There wasn't one this time, so you don't have to worry about that part. So the first 17 dots, you then have to find the median of. That would be the 9th dot, which in this case turns out to be 29. Now for the third quartile. That would be 9 dots from the maximum, which in this case would be 32. Now that we have the 5-number summary, we first start by making our box. That's going to be a box that spans from our first quartile to our third quartile. So from 29 to 31 will be where our box is. So that shows 50% of the data. That box right there is 50% of the data in the dot plot. Now we draw the median. which is 30. So now each little box is 25% of the data. So this box is 25%, this box is 25%. This box makes up what's called the inner quartile range, and we'll get to that in a moment. Now, you may also have heard of a box plot called a box and whisker plot. So now let's draw the whiskers. Each of those will be 25% of the data. And those will go from each of the quartiles to the minimum or the maximum. So first from the first quartile to the minimum, so from 29 to 14, and from the third quartile to the maximum, so from 32 to 35. By the way, just a reminder, looking at this data, is it symmetrical or skewed? Skewed. And skewed left or right? Left, because the tail goes to the left. So now for things you can learn from a box plot. So first of all, each section is 25% of the data. So the smaller the section, the more data that lies in that area. So this line is really, really long. That means there's not a lot of data here. As you can see, only a few points. This box is really, really small, meaning there's a lot of data there. As you can see, lots of data. Lots of dots. This one's a little bit bigger, and then this line is a little bit bigger. So both of those have a good amount of data in them, but nowhere near as much as this section here. Now, one thing you can find from a box plot is what's known as the range. The range is how big is your graph? How far does it go? And you find that number by taking the maximum, 35, and subtracting the minimum, 14. So the range in this case would be 21. Now, you can also use this information to find what's known as the inner quartile range, also known as IQR. That would be taking the two quartiles. So you want to find what's the range of the center 50% of the data. So that would be Q3 minus Q1, or in this case 32 minus 29, which in this case is 3. A very small inner quartile range. So in this case, 50% of the data lies within 3 units, or in this case, 3 raisins. The last thing I would like to talk about here is outliers. Now, statistics is very not exact, and different statisticians use different things. And with outliers, they're not always used. But the definition of an outlier is this. An outlier is any data point that is more than 1.5, so 1.5, times the IQR from the nearest Q, quartile. So the inner quartile range is 3. So an outlier would be anything that is 1.5 times IQR more than 1.5 times IQR from the nearest quartile. So first, 1.5 times IQR is 4.5. Put that right here. So anything more than 4.5 from the nearest quartile. So on the right end, we'll look, the nearest quartile is 32, and 4.5 more than that would be off the graph. So no outliers on the right side. The left side, however,
the quartile 1 is 29, so 4.5 less than that would be 24.5. So 24.5 is the mark where everything to the left of that would be known as an outlier. So if you were going to point out the outliers in this graph, what you would do is, instead of this section here being this whole line, you would actually stop it at the last dot before the outliers. So that would be 25. And then you would put a star on every outlier that shows up. So your graph would actually look like this, with a star here, here, and here marking the outliers. Now, not all graphs are written like that, and usually they just put all the data straight through. But if you want to mark the outliers, you can like this.
Now time for the sponge. So, 3 parts. First part, a data set consisting of the number of hours each of 40 students watched television over the weekend, has a minimum value of 3 hours, a Q1 value of 5 hours, a median of 6 hours, a Q3 of 9 hours, and a maximum of 12 hours. Draw a box plot representing this data. So in the video, we calculated those numbers and then did the box plot. Here, all you're doing is just taking those and making the box plot here. So use those numbers they give you and make your box plot. Number 2, what is the interquartile range? And then what percent of the students fall in the interquartile range? And then number 3, do you think the data distribution is skewed? Why or why not? That's it for the lesson. Once again, please make sure to take notes on the entire lesson. Go back, rank yourself, attempt the sponge, please do it. Take a picture of your notes, submit it all to eBackpack, and have a good night.